Hello, I'm Lilia. In this video, I'm going to explain what acts as centripetal force in a bank turn without any friction. If a road is flat and a car wants to turn a corner, the only force acting as centripetal force is friction. However, inclining or banking a road adds an additional force that keeps the car on the track. So as a result, the maximum speed that the car can travel increases. So a bank road, as you can see here, is a turn in which the road inclines toward the inside of the turn. The edge of the road on the outside of the corner is higher than the inside edge. The result is a net force in the direction of the corner. On the image, the first thing that I'm trying to do is drawing all forces acting on this car. We know one of the forces acting on car is weight. We have W, and we have normal reaction that is perpendicular to the surface that car is on it. So this surface normal reaction is perpendicular to this surface. So normal reaction is N. And we said no friction, so we don't have any friction in this case. Right now we want to see what force acts as our centripetal force. We know centripetal force should be a net force in this direction. So F net, that is equal Fc, should be in this direction. We have W that we see W doesn't have any component in the direction of our centripetal force. But when we look at N, if we resolve N, we can find two components. So resolving N is Nx, and we have Ny. If we say this angle is theta, if we use our math knowledge, we see this angle also is equal theta. Okay, right now, because we know the car is not accelerating vertically, so sigma Fy should be equal 0. It means W plus Ny should be equal 0. And sigma Fx, that is equal Fc, is equal Nx. If I draw the triangle for N here, then we can discuss it better. So this one is Ny, and this one is Nx. And if this angle is equal theta, so Ny is equal N cos theta, and Nx is equal N sine theta. So right now, if we look at sigma Fy, that is equal W plus My equal 0, and we substitute My which is equal, and so it's W, we know it's equal Mg, and My is N cos theta equal 0. As a result, N is equal Mg cos theta. However, in terms of magnitude, it's equal this. However, its direction is opposite of direction of W. And right now, if we look at sigma Fx, that is equal our centripetal force, or Nx, we can say this one is equal N sine theta. Right now we have two equations. Right now we have these two equations, so I can write Fc is equal Nx is equal N sine theta. If I substitute N with its equal, I can say it's equal Mg cos theta times sine theta. And we know sine theta divided by cos theta is equal tan theta. As a result, we can say FC is equal mg times tan theta. So far we saw nx equal n sine theta, ny n cos theta. As a result, we found our n. And Fc, or centripetal force, is equal nx, and as a result we found Fc equal mg tan theta. In addition, we know Fc is equal mv2 divided by r. As a result, I can say mv2r is equal mg tan theta By using this formula, we can find the maximum speed that a car can travel on this road in order to stay on track. Okay, let's go through one example. Calculate the maximum speed of a car traveling round the corner with a radius of 20 meters. So radius is equal 20 meters and a banking angle of 10 degrees. We don't have any information about mass of the car, but we know, and the question hasn't said anything about the friction, so it means it's a road without any friction. So the only force that here acts as our centripetal force is x component of normal reaction. That we prove formula for V max, and it's equal Rg tan theta. So V max equal to 5.88 meter per second. However, if you get this question, you need to prove the formula before solving the problem. I hope you found this video helpful, and thank you for watching.